a common base. That Math Excel assignment from yesterday is due by the end of the day today, otherwise it will be late. So if you don't have that done, which is a few of you, I expect to see you in advisory today. Today's portion, we are looking at log equations. So we're actually going to have a couple different options with our logs, and it's going to depend if the equation has a log on one side or both sides. So if you have a log on both sides of the equation, then you are able to drop that log. It's just the reverse of the property we did yesterday, where we could take an exponential and add a log to each side. If you're starting with one log on each side, you can take that log away. The other option that we would do is if we only have a log on one side, then we can change it into exponential form. So I believe this is where we left off yesterday. So I kind of broke these up on your notes handout to give you the different strategies. When we have logs on one side only, we can change it into exponential form. However, in order to change it into exponential form, you have to isolate your log first. We can only have one log on the side. So when I'm looking at this, I need to do something about the 5. And you really have two options. Properties of logs say you could turn that into an exponent, or this is 5 times log, we could just divide it over. So would you rather just divide by 5 or have something to the 5th power to do? Divide. Probably be much nicer. So then we have log of x plus 3 equals 2. So since it's only on one side, I can't just drop the log, but I can do the definition. What is the base on this log? 10. So the definition, this means 10 to the 2nd power equals x plus 3. Subtract that over and we get x to be 97. You do want to make sure you check on these because they started with logs. We know that when we're dealing with logs, the argument has to be positive. So all you really need to verify is if I plug in 97, is 97 plus 3 a positive number? Yes, so my answer is okay. If I were getting a negative when I plug that in, then I would have to say that there was no solution for the equation. All right, is that okay? So let's look at this. All right, can I just divide my 3 over this time? No, because I have 2 logs. So we have to use the properties of logs to condense this. First thing I could do is take this 3 and move it up into the exponent. And then we know if you have 2 logs subtracted, you can turn them into 1 by division. So this is x minus 1 cubed divided by 4 equals 5. Once you have a single log, before that, change it to exponential and get rid of that log first. So it would be 2 to the 5th power equals x minus 1 cubed over 4. So 2 to the 5th is 32. So multiply by the 4. All right, what would I do now? You could choose to multiply this all out, but it's not going to be nice. We could just cube root each side. Do I need a plus or minus? No, because it's an odd root. Does this work out perfectly? No, so I'm just going to leave it as the cube root of 128 for a second. And then what would you do to get the x by itself?
What would that work?
So we have the cube root of 128 plus 1. Or if I asked for the decimal approximation,
6.029.
and then just a quick check, the arguments have to be positive. So if I'm plugging in a 6 point something, subtract 1, that's positive, so we're all good. Okay, so if I'm looking at this one, we have multiple logs again, but does everything have a log? No. So let's try to get those logs together. So what would I do? Add over the natural log x squared. If these logs are added, how do we combine them into one? So x times x squared. If you have a natural log, what's the base? So this means e to the 9 equals x cubed. Cube root it. When you're doing a cube root, it's just like dividing those exponents. What's 9 divided by 3? So this is e cubed. Or if you actually wanted the decimal, we could type that in. So the exact answer is the e cubed. The approximation would be 20.0855. Quick check, is that an okay answer? Yeah, everything's positive there. Why don't you guys take a second and see how far you can get with this one?
You're thinking that was a steal because I don't drink tea. That's not even tea.
Which equation do you plug it into?
The original.
So like a log?
Yeah, you're making sure both of those are positive. Okay, so if our logs are added, how do we combine them? Multiply. So we have log base 2. So you don't necessarily have to write this step. I'm writing it just to show you what we're doing. We're going to multiply those two things together. So we have to FOIL. We get x squared plus 8x and plus 7x, so plus 15x plus 56. Then if there's a log on one side, change it into exponential form. And what do we do? The first is just 2. Quadratics we always set equal to 0. So what multiplies to 54 and adds 15? And then set each of those equal to 0, so you get -9, -6. Okay, you cannot just look at those and say, oh, both of those are negative, neither one works. You have to check when you plug them back in. So -9 plus 7 is negative, so that's not going to work. -6 plus 7 is positive. -6 plus 8 is positive. So -6 is the only answer that works here.
I just looked at the -9 and checked it, and I didn't even check the -6. I was like, nope, none of it works.
Just mark them off, huh?
Oh, Did you take off one thing but didn't put the brackets around the two?
No, I was just showing you
Okay.
what's going on there. All right, last type of problem today. So all the problems that we've done so far had some terms with logs, but you had at least one term that didn't have a log, right? So our strategy was to get all those logs together and then change it into exponential form. The last type of problem we might have is when everything has a log with it. What do we do in that scenario? So we want to use the strategy that if we have just one log on each side, we can drop them out. Now before that, when I'm looking at this problem, we have to first deal with this 2. Is it going to help me just to divide it over to the other side? No, that just moves the problem. So change it to an exponent. So that's log base 5 of x squared equals log base 5 of 9. Yep, we drop the log base 5, so we just say x squared equals 9. So then we can square root, plus and minus. So we get positive and negative 3. Check. Can you use positive 3? Can we use negative 3? No. So positive 3 is our only answer. So next one. What's our strategy? So we have to get rid of the 1/2 and the 2, so we can turn them both into exponents. So we have log base 3 of x to the 1/2 equals log base 3 of 2 squared. Then we can drop the log base 3, so x to the 1/2 equals 2 squared is 4. And 1/2 is like a square root, so to get rid of it, you square. And we get 16, which is positive, so it works. Couple more.
On this one, can't we just jump right into it?
We cannot. The property requires
Oh,
one
that's
log on each side. So we have 3 logs. We have to condense it into 1 log on each side. If these logs are subtracted, how do you put them together? So we have a natural log of 24 over x plus 4 equals a natural log of x plus 6. Then what? Yep. Drop those natural logs, and then if you want to get rid of the fraction, you can multiply the x plus 4. So if we FOIL here, we get x squared plus 10x plus 24. Quadratic, we always set those equal to 0, so if you subtract the 24 over, then how do we factor that? So we get x to equal -10 and 0. Check them. Go back to the original. If we put in 0, are all the arguments positive? Okay, what about with -10?
No.
No. So x equals 0 is the only answer that works. So when logs are subtracted, how do we put them together?
Butterfly.
So we can drop our logs. So then we just need to cross multiply. When you do that, you have to FOIL.
So we couldn't just, multiply the right side by 2 and have a common base and then add the top? Never mind.
No.
I didn't do it, I was.
Oh. Say that again.
No, never mind.
Multiply, the right side with 2/2 and then have a common base, you can like subtract it over so you can combine the numerator.
If you did that, it would not be a common denominator because it would be 2x plus 6 on the bottom. But yes, if you could get a common denominator, you could go that route. So we x squared plus 2x minus 3 when I FOIL those two. Those two, we get x squared plus 4x minus 12. So if I subtract my x squared over, yeah. Alright, okay.
You can add your 12, and you can get 9. You have 9 equals 2x, and you divide 2, and you get x equals 9/2.
And then you have to check that every argument is positive. If one of them is not, then it becomes a no solution here. 9/2 is 4.5, so 4.5 minus 1 plus 6 minus 2 plus 3, all of those are positive. So that does work.
Unfortunately, my brain does not work that way. Okay. I'm not in math, so.
I don't know what it is. Alright.
Questions here?
Wait, that's on the chart now?
Okay, so today we are stopping here. We've covered everything from this section. Tomorrow is going to be a review day, so we'll do the extra examples, just kind of mixing everything together with what you do in each scenario. And then if you're gone tomorrow, it will be a handout posted on Classroom with just the review. So we will have
What's
that.
tomorrow?
So it's Math Excel again today. And if you don't have yesterday's done, make sure you're getting that completed as well.
Alright, problem, that's not like.
Tons of blocks today. He literally
Watch your
went on
language,
and had
please.